Okay, so if we go sketch the graph of y equals 2 minus x to the 2/3, we first check for asymptotes. There are no asymptotes, so let's try to find the zeros. So we say 0 equals 2 minus x to the 2/3, so x to the 2/3 equals 2, so x equals 2 to the 3/2, which is, let's see if we can't, this is the square root of 2 and it's cubed, so that would be 2 square root of 2. Plus or minus 2 square root of 2. So we have some zeros where we can, like I'm going to put the graph right here. So I know I have a 0 at 2 square root of 2 and negative 2 square root of 2. Okay, so let's try to see if there's a y-intercept, and if x is 0, y is 2. So we know we have a y-intercept at 0, 2, so I can put that point in there. All right, so now let's take the first derivative. So the first derivative is negative 2/3 x to the negative 1/3, okay? Subtracting 3/3 and we get negative 1/3, and that's equal to negative 2 over x, 3x to the 1/3 equals 0. So there's no value that makes the derivative equal 0. So no critical points. Do we have a place where it doesn't exist, where the first derivative doesn't exist? And because there's an x in this denominator, yes, it's undefined at x equals 0. So that means we have a cusp. There are no asymptotes, so it's a cusp or a corner. Okay, and we'll figure out which one it is when we do the second derivative. Let's look at number 3, or this was the first thing you're supposed to do. This is the second, and so this is the third. Second derivative is, okay, that would be 2/9 positive x to the negative 4/3. All right, and so if you set that equal to 0, again, you don't have any places where it's equal to 0. So you got to see, is it positive or negative? It'll be the same for each one. So it looks like if I say 2 over 9x to the 4/3, that's always going to be greater than 0. So this is going to be concave up everywhere. Okay, so I have to say, okay, it's concave up everywhere. It has a cusp, so we're going to go do like that. And it has to go through 0. So wouldn't this be 1? And this would be the other. That's concave up, cusp at 0, and concave up on this side. So that's how you would graph number 3, and we'll do one more.